Alt-L, functions. In this video, we'll explore how functions in computer programming are related to functions in mathematics. So a function in Python and in other computer programming languages is a subroutine of a program which may be called to execute when needed within the main program or even another function. Arguments are variables that are sent to functions and may be used by functions to run their code. Functions may optionally return variables to the line in the program from which they were called. Mathematical functions are relations between sets of x and y values, for which each allowed x value has one and only one y value. We'll see that that's very important in mathematics, and we can explore this feature of mathematics using computer programming. Python functions may be used to model mathematical functions. Here we have 7 examples of functions which illustrate the use of functions in Python and begin to explore the nature of functions in mathematics. So the very simplest function we can imagine is a single line function. This structure is similar to the decision structures and the loops that we have seen in the previous videos. We start with def. Def stands for define. We're defining a function, print something. Note that print something is followed by 2 brackets, and those brackets are empty for the moment. In the future examples, we'll see the use of the brackets. There's a colon, and on the next line, we have a tab, and this is the repeated Python coding structure that we see in the decision structures and loops, and in other parts of Python. This function simply prints something. And that's all. That's about the simplest function you may make, almost. The second example, example 2, we will print an argument. Now we see the brackets have a variable in them, the variable x. This function will print the variable x, and when you use the function, you have to call it and send a value to the function, and we'll see this later in the video. So this function simply prints the variable x. Now we continue along. Here's where we start our connection to some mathematical functions. The next 4 functions illustrate 4 different types of polynomial functions in mathematics. Each one has powers of x. The first one is a linear function, and the highest power of x is x to the first power. X is not multiplied by any other x's, that is. So this function will take a value of x, and it returns 3 times x plus 2. This is called a linear relationship in mathematics, and a very important part of mathematical learning. And of course, this is the relationship used to describe lines in mathematics, straight lines. As we move on, we go to higher powers of x. The second one here is a quadratic power of x. So this function is still f at x, and it returns 3 times x squared plus 4 times x minus 2. So there's the highest power of x, x squared. And finally down here, we have the third power of x, represented in this function. It's a cubic function, x to the 3rd power plus x to the 2nd power. We can write it like this as well, plus 5 times x to the 1st power minus 10. So we'll note here I've named them all f, and this actually will not work, because if I name them all f, then they cancel each other out, and only the most recent one will be defined in Python's naming list. So here I've put an f1, f2, and f3 for a linear, a quadratic, and a cubic. And later in the program, we'll adjust it to call each one of these in turn. So example 6, mathematical function with 2 variables. So here we pass in 2 arguments, x and y, the variables that are described in this function, 10x squared minus y cubed. And this gets returned. So this is a multivariable function, and very easy to model and use in Python. And here we have a function that calls another function. and that's a special feature of functions. Each function may call other functions, and you can have quite a complex arrangement of functions within Python to achieve more complex outcomes. So in this case, whatever h at x is, it's f at x times x. So if x is 1, then f at x is 1, or h at x is 1 times f at 1. So there's the reference of another function within this function h, and that's perfectly fine. So now how do we use the functions? The first two are functions that do not return anything, we just call them. So I just execute this command, print something, and if you recall our first function there, it prints something. The second one, print variable, and we send it an argument, print this please. So x now becomes print this please, and it will print it out. So now I've referred to f at 10. I'm going to repeat this statement 3 times, but because I need 3 functions, f1, f2, and f3, so that we don't overwrite them. Here we go. Now I've modified the code. So functions that are returned, or that have return at the end, they may be printed out. So this f1 at 10 becomes a value that you can print, and it's inserted here in this print statement. So the 3 functions, f1, f2, and f3 at 10 will be all printed in turn here. So there's our multivariate function, g57. Oh, maybe I should change that. It's actually g53. And finally, we can show not only may you print these function values, the ones that are returned, we can also set them into variable values. So h value is the return value of h at 10. And then we can print out the value of h value here. So now the code may be demonstrated. We press play. Perhaps we can make the text a little bigger before we press play on our code. And here we go. And we have a problem because f has not been defined. If you recall, we changed f1, f2, and f3, and there's a typical error within Python. No problem at all. We'll just change this f right here. It tells us the line where we need to change it. Here we go. So print something. There's something. Print this, please. Print this, please. And here are 3 functions, f1, f2, and f3, and their 3 function values at 10. g53 ends up being 223, and the value of h value, which is h at 10, is printed here. There we have our use of mathematics, or use of Python functions to model mathematics functions.